Hello everyone, can anyone please confirm the audio and screen share before we get started? Yeah, please type in something in the chat, just you can hear me and see me clearly. Looks good, thank you Fatima. Let me make you an admin just for the yeah, so you are gonna be a moderator. Okay. So good morning, good evening, good morning, good afternoon, good evening. Assalamu alaikum wa rahmatullah. It depends on from you are joining the program. Welcome to Big Bang Data Science Solutions, the NLP 10-week free program. And today we are gonna cover week number 5. But as a matter of fact, we did not do week number 4. So we are going to go and do part of week number 4, and if we have time, we are going to do week number 5. But literally, it's week number 5. So today we are going to learn how to clean data one more time, and we are going to add on the top of that, we are going to learn how to extract features out of the given data, cleaned given data. So that is the plan. So everybody, if you can please share the link to in your social media, that will be great. Please let's share the knowledge by simply sharing the link in in your social medias and invite your friends, your network. So please do that. If you don't have if you don't mind, please. Okay, folks. So this is what we talked. In this session, we'll talk about NLP pipeline, the process of pre-processing the data, and also we are going to talk about the NLP feature extraction. So let's go through the slides first. Then, of course, we are going to jump into a lecture in the hands-on in Python. So this is what we talked about last week. We talked about the pre-processing steps where we had the data, we tokenized it using different methods, and today we are going to repeat this very quick. Then we removed stop words, and we did some stemming and lemmatization, and of course we did normalization. So these are some of the processes or steps that we applied to our text last week. Yeah, today we are gonna try to extract some features using a few of available techniques. Of course, we are not gonna cover every single method of extracting features. So the process when we are the process of handling text data is number one, we need to tokenize it. Means we need to split a text into tokens, simply into words and into separate words. So we can navigate through them. We can navigate through those list of words to remove any stop words, any common words, any words that might not add any value to our analysis whatsoever. It could simply slow down the process of process of pre-processing. So we might need to remove any unneeded, unwanted, or unnecessarily words through navigating through the given tokens and remove the stop words. So we might need to stem Stem is simply find the stem of the word or the root of the word, and by removing the ending. And lematize, sometimes we might need to stem, and stemming sometimes can make or create some problems in terms of the meaning of the word, of the correct spelling of a word that been stemmed. Lemmatization, it compares the stem word to an online dictionary and correct it accordingly. So then we need to tag the words. Now we need to find the words part of speech that would help us to understand the true meaning of the word. And after that, we extract information, extract some insight or meaningful information that would help us to make a better decision. Regardless if you are working on a text data or a different type of data, the process of handling, or the process of conducting analytical project, it's still the same. So always you are gonna connect to a source of data. It could be flat files, it could be web scraping, it could be a database, it could be a data scattered everywhere. So we connect to a source of data, then we collect the data that we are looking for. Of course, we don't need to read every single bit of the data that we have stored in a database. That is too much to handle. So we are going to simply extract, or we are going to simply read and collect the data that we know we are going to need to conduct this analytic approach or this analytical project. So we collect the data, and of course the data that we have in hand at this point of time, it could be a data that it could be too much data, it could be little data, it could be right data, but it has a lot of quality problems. So we still need to get that data, extract some features that that we know that we are gonna need. So we need to select features. Sometimes features are not available. So what we could do is generate or engineer features out of the existing features, out of the given features. So we need to feature extraction, feature engineering, feature creation, feature selections. Then we need to clean the data, enrich the data. Sometimes we might need to transform the data, especially if you have categorical data. We might need to transform categorical data into numerical data, especially if we are planning to apply machine learning and scientific methods. Machine learning is simply some statistics and math functions applied on a given data to learn about a structure, learn about a signal, learn about a relationship. So these mathematical functions deals with numerical data better than categorical data. So we might need to transform our data, and sometimes to help us really understand the data better, we might need to visualize the data. We might need to transform a data, the given data, into a graphs. It could be bar plot for categorical data, histogram for numerical data. It could be scatter plot to determine the magnitude and the direction of relationships between two plus independent numerical variables. It could be box plot to determine the outliers. It could be line plot for connecting the dots in a time series. It could be heat map. It could be anything. So after we prepare wrangle our data, then definitely we can this is all pre-processing, preparing the data, making the data ready for the analysis. Then the second step of the process is modeling this data, modeling and training the data. Is taking the data that we already prepared, make it ready to go, Then now we are going to apply some algorithms. It could be machine learning, it could be a specialty within machine learning called deep learning, it could be an NLP, it could be any modeling techniques. So we are going to model and train, and after that we of course it's going to go through a whole process of training, testing, validating, and if we are if we are fine, or if we are okay with the process, then we deploy. We implement what we call MLOps, simply deploying the model into production. And once we deploy the model into production, then we need to monitor the progress. We need to keep our eye on the performance of the model, etc. So the same process applies regardless of the type of the data that you started with. You could start with structured data, semi-structured data, or quasi-structured data, or unstructured data. Unfortunately, as per statistics, 90% of the data circulating worldwide now is unstructured data. And most of the scientific methods, statistical method, algorithms, modeling, they are designed to work around the structured data. Machine learning don't really understand unstructured data. They understand the structured data better. So what is structured data? So structured data is a tabular format, is a tabular format where you have rows and columns. That is a structure. An example is CSV files, Excel files. So we have rows and we have columns. And as I said, most of the machine learning algorithms and deep learning algorithms and NLP algorithms, they are designed to work better around the structured data. Another type of structured of data is semi-structured data. It's not tabular format. It's very close, but still it's not in the tabular format. So XML is an example. HTML files are an example. We could extract a table, structured data out of semi-structured data, but we have to have with little effort. With an effort, we could do that, but it's not really a structured data. It is all the data is within the tags, and we could simply transform that into a table. But as I said, there is an effort. A third part, or a third type of data is quasi-structured data. Is similar to semi-structured data, but it's more. It's too far for being structured. An example is a web clickstream. There is a kind of embedded structure in it, but it's not tabular. Then this require a great amount of effort to transform it into structured data. And finally, and this is what we are going to handle today, is unstructured data. 90%, as I said, of the data being generated on a daily basis is circulating worldwide is unstructured data. There is no non-structure. There is no rows and columns. And this is what makes it a challenge for machine learning and deep learning to handle, to deal with, because as I said, machine learning and deep learning algorithms, they are designed to work better. They are designed around structured data. Example of unstructured data is PDF files, images, videos, text files, documents. So there is no for this type of data, there is no there is no rows and columns. There is no noun structure. So text data, images, audio, and video. And here comes into the pictures the process of NLP. And NLP, it does handle this type of data, especially the text part of it. So today we are gonna learn about this. How we can get structured unstructured data text in our example. How we can pre-process it, clean it, and extract features or transform it from an unstructured format to a structured format that we can use machine learning. So that is the process we are going to learn today, and we are going to learn how to transform unstructured data into structured data. And next week we are going to learn how to apply machine learning to model it and for prediction and modeling. So hopefully this is clear. If not, so please feel free to ask your questions. Yeah, please feel free to ask your questions and under live. Okay, so as a matter of fact, I already uploaded the files. So if you have access to the canvas, yeah, please, if you have access to the canvas, you should be able to download the files. Otherwise, please reach out to us. We'll be more than happy to assist you with your access or to troubleshoot your access to the portal. So for those who have an account with us, you should see this course in your canvas. Of course, you are not going to see everything because I'm an admin. So click for natural language processing, click on modules, and you are going to see all the previous weeks. So we covered week number 1, week number 2. Week number 1 we covered why learning data science is an absolute mess. Then we moved into a crash course in Python programming in week number 2. Then in week number 3, an introduction to natural language processing. And week number 4 is a continuous of an introduction to natural language processing. And today we're supposed to do development and text classifier, but we are gonna learn how to extract features. So click on the training materials. Then you should be able to have access to Dropbox, where you are gonna see the codes. You are gonna see the presentation. It's there, the presentation of today. And also you are going to see the codes and the data. So this is why I want you guys to download. If you want to follow up with me, otherwise please keep watching, and you could deploy this or try this later after of course the class. So yeah, we are going to do is we are going to fire our Jupyter notebook, and I'm going to simply grab the file from the folder, and it's week number 5, code and assign codes, and this is the file. So I am going to zoom out a little bit, actually zoom in a little bit. So if you can see it clearly, please say something in the chat. Yeah, please say something in the chat just to make sure that you guys it's clear. Yeah, anyone, please say something in the chat. A little closer. Okay, it's 150%. Great. Okay, so as I said, we are gonna redo a process. And by the way, this is the this is the text we are gonna use. Simply, I grabbed random. I'm gonna put this in the chat if you guys wants to grab the data. So I went to this article. It's simply an article, a random article. And I simply copy paste some sentences. This is all I did. Is parents of accused killer in Michigan school shooting arrested after vehicle was found in Detroit. So all I did is copy paste some of the sentences, and that is what I did. Okay, so we are going to apply some NLP on this article. Okay, so we are going to grab this article, and of course we are going to clean it. Yeah, we are going to clean it. Number one, we are going to use tokenization. We are going to apply some stemming. We are going to apply lemmatization. Then we are going to remove the white space and stop word removal. So few things that we are going to do to prepare this data for the analysis. There are many methods that we can utilize or we can use to clean the data. One of them is the RE or regular express library, which is simply a library that uses the string searching patterns. It simply goes through a text string by string and compare these strings to a given list of items and remove if match. That's simply this regular express what it does in a nutshell. Of course it does many things, but this is what we are going to use it for. So the first thing we gotta do, as usual, is we are going to import the library. You don't have to install it. We are going to import it. Now running the first cell. Let me restart the kernel, please. Okay, so the first thing we gotta do is import the library, and as usual, we are gonna create a function. No, so we are gonna create a function, and what this function does, simply a function. You could give it whatever name you want. It takes one variable. It takes one parameter, and we are gonna compare that parameter to a list of regular express objects. And so we are gonna take that one parameter. We are gonna split it. We are gonna tokenize it. We are gonna split it into words, into tokens, and we are gonna compare those tokens to a given regular express parameters, and if there is a match, then we eliminate, we remove. So simply what this code does, it is gonna split the given sentence or the given data set, given data. It's gonna tokenize it. It's gonna split it into words. Then it's gonna navigate through these words, and it is gonna remove anything that is not string. So it is going to move anything that is non-alphanumeric character. So it is going to remove special characters. It's going to remove numbers, digit. It's going to remove also the punctuation. It's very simple. This is how powerful this regular express is. So we are going to create a function, as I said, that takes only one parameter. Then we are going to split that parameter. We are going to split it into tokens. Then we are going to search match with the given regular express parameters. Then we clean the data accordingly. We are going to eliminate features that meet certain criteria, or we are going to eliminate tokens that meet certain criteria. So run it. All I did now is simply create a function called clean text, and this clean text, this is what it does. It applies a regular express to entire given data after it's split it into tokens. Okay, so if we go to the article I shared with you, okay, so all I did is I copy paste, make a copy and paste. This is all I did. So I created a sentence, and it's a variable, and I copy paste the entire probably a long paragraph. Okay, let's take a look. Yeah, it's simply a paragraph. I could do more than this. So this is the one that I copy paste for simplicity and for the training purpose. I only copied this paragraph here. So just if you want to follow up, this is the paragraph that you want. You could try many paragraphs. That is fine. But for simplicity and for the training purpose, we are going to copy only one paragraph. Okay. So now we have the paragraph, and now we are gonna pass this paragraph to the function that we just created. So this is the paragraph that we have, and now we are going to clean it. Of course, it's going to go through it. It's going to remove the punctuations. It's going to remove the apostrophe. It's going to remove anything that is not alphanumeric. It's going to keep only non-alphanumeric characters. Let's try it. Here we go. So we got the gun had been, and I don't see. You wouldn't see any. You wouldn't see what we call the punctuation. If I were to do, for example, if I want to add special characters, for example, let's try to see if it's going to work. So I added question mark plus equals 67, the gun, and we got special characters. So I'm going to run it to see if this regular express is going to remove this nonsense, special characters and numbers from the sentence being provided. So let me update the sentence. So we got it in there. The gun question mark plus equals 67. Now I'm gonna apply the regular express function. So it keeps 67. It removes. So it is gonna keep number digits and the characters, but it's gonna remove special characters. So that is what it does. So this is one way of cleaning our given data by simply applying it against a function that takes one parameters and apply a regular express on a given data. Okay, so sometimes using a regular express on a sentence, of course it splits after cleaning our given data. It's split it into tokens. So the is a token, comma, gun is a token, the gun had been. So we lose a meaning. This you wouldn't see the true meaning of a word. So what we need to do sometimes this is what we call them collocations. Is we want to display not only one word or one token at a time. How about if we were to display 2 tokens and 3 and 4? So that would help us to make a sense of the meaning. So to do that, now we are introduced to a concept, bigrams and trigrams, etc. Concepts. So this or what it does, is printing 2 words that go together, 3 words and 4 words, etc. So this is what this collocations does. An example here, for instance, if I have a sentence says I don't hate you, but your behavior. If we were to token this sentence after, of course, we clean it, we remove any non-character or non-digit, we might end up having a sentence that does not make sense, words that don't make sense. But if we were to put them together, then we can extract the true meaning of the sentence. Okay, so it's the same thing. We are going to create another function And this function, what it does, it takes two parameters. It takes the data and a number, and of course it does pre-process it. It removes anything that is non alphanumeric. It keeps only the alphanumeric, removes the special characters, and it displays the tokens, plus it displays a number of tokens, that the number of tokens that you want to display together. It could be 2 tokens together, it could be 3, it could be 4, it could be whatever number you want. So I'm gonna run this. I'm gonna create the function ngram extractor. This is the function we are gonna apply, and then we are gonna apply it. Yeah, so this is the function which I just created, and as I said, this function, it takes 2 parameters, 2 inputs. It takes my sentence or the data, and it also takes a number of how many words, how many tokens you want to display together. So that is called a gram. So it could be a bigram, it could be trigrams, it could be quigrams, it could be different numbers. So we are going to apply this function. We are going to apply the function we just created on the text, on this sentence. Okay, so let's do that. And now we got 2 words. The gun had been stored, etc. So it's 2 grams together. You could change this. You could change this number into 3, into 4. If we were to do 3, so we got the gun had been stored in. So it puts the tokens together in a sense that helps you understand the true meaning of a word. It's better than simply going through the list of words that might not make a sense. Yes, of course you understand the meaning of a word, but the word change when you put it either together with different word. The meaning of a word changes by adding words to it after or before. So a word by itself might have a meaning, but when you have a word before or after, it could the meaning could change. That is why it's very important to apply the collocations to help us understand the true meaning of a word. And it can take any number. If you want to do, for example, 5 words, you could do that. So here you got 1, 2, 3, 4, 5. The gun had been stored. Gun had been stored in. Had been stored in and been stored in and unlocked, etc. So you see the position of a word within a sentence, and also you understand the true meaning of a word. That is what we call the collocations. Okay, and we could do these collocations, bigrams and trigrams using many methods. We could build a function using a regular express, or we could simply use the scikit-learn. Now scikit-learn does it for us. From scikit-learn we need to import the ngrams method. N stands for a number. It could be 2, it could be 3, it could be whatever number. So we import the ngram from scikit-learn. I'm sorry for NLTK, not scikit-learn, my apologies. So we import the ngram from NLTK. This is natural language processing toolkit. So we import the toolkit for natural language processing, which is a package for pre-processing text and speech. And we import a method called ngram. So we import the method, and we apply the method into a sentence, into a given data after, of course, we split. So the first thing we gotta do is we need to split this data into tokens, into words, and we apply the n-gram, the method, on the split data. And of course, we need to specify how many grams, how many n-grams that you want to extract. So we could do 6, for example, 6 words. Here we go, and we apply it. Then you are going to get 6 words. You got 1, 2, 3, 4, 5, and 6 words all together. You could do 2 words, 2 grams. So it's better. It's of course it's fast, and it's two lines of codes compared to a regular express, which takes a function. Then within a function, you need to take an action, and so you need to specify the input, the parameters, take an action, then return something. Okay, so n-gram for n-gram does a better job for n-gram methods from the NLTK. Okay, let's do 3. Here we go. So we got 3 words, 3 tokens together. As I said, this is simply a number. The n-gram, n stands for a number that of your preference. It could be 2, it could be 3, it could be more than that. Sorry guys, I need to fix. Here we go. So I need to fix the position of the camera. Okay. So again, we are gonna tokenize. There are many methods to tokenize, to split our given text into tokens, into words, and that would facilitate navigating through these words, compare them to a string, compare them to a pattern, and take an action accordingly. The action could be a removal of patterns, a removal of a string, a removal of a character, removal of a behavior. So there are many methods of tokenization. We are gonna cover a few of them, and of course they have some pros and cons. So you might need to be careful about it. You might need to try all of them and determine which one is. We might try to try these methods with a small sentence, a sentence that you know better, and determine which one yields a better result and apply it on the entire data set. So we are going to learn the white space tokenizer, tweet tokenizer, MWE tokenizer, regular express tokenizer, which we already covered, and word punct tokenizer. So there are 5 tokenizer method that you could utilize to transform a given text into words, into tokens, and that makes it simple for the system to navigate through, to loop through, and compare the given token, the given text that have been split into tokens with patterns, with and take an action accordingly. So we are going to import them. They are all available through the natural language processing toolkit package. So we are going to import tweet tokenizer, MWE tokenizer, regular express tokenizer, white space tokenizer, and word punctuation punct tokenizer. Of course, you don't need to use all of them. Just use one of them, but you need to find out which one works better for your scenario, for your case. One method could work for a case better, and it could work different for a different case. So you could try a very small sentence before you apply them on large data set. So what we got to do here is we are going to create 5 functions now. So the first function is tokenize with the tweet tokenizer, tokenize with MWE, tokenize with a regular regexpress or regex tokenizer, tokenize with WST, which is white space tokenizer, tokenize with word pank tokenizer. So we create, this is simply a word, this is simply a name of the function. So all these functions, they take one parameter, and that one parameter we apply the method, we apply either a tweet tokenizer method, MWE tokenizer method, regexpress tokenizer method, or white space method, or word pank tokenizer method. So we take a parameter, we take an input, then we apply the method, and we return the input after we apply the method. Very simple. So create a function, takes one parameter, we apply the method, the tokenizer method on that parameter, and return to we return the tokenized input. Very simple. So I'm gonna run this. I'm gonna run the first function. I'm gonna run the second function. I'm gonna run the third and the fourth and the fifth function. Okay, and we are gonna apply them. Yeah, we are gonna apply them. Sorry guys, I have to run this first. So yeah, we are going to import all the methods from the NLTK, and of course this is the sentence we are going to use, but let's use a very small sentence. Yeah, we are going to use a very small sentence. Let's say very simple, love to learn NLP. Thank you BBDS for offering this training program for free. For example, this is a very small sentence, so we know it. We know this is a sentence. We have a comma. Love to learn NLP in 2021, for example. So we got some we got some numbers in there, we got some comma, and let's do this exclamation mark. Okay, so we know the sentence, here we go. And let's take a look into the sentence to make sure that we got it. Here we go. So love to learn NLP in 2021. Thank you BBDS for offering this training program for free. Bum bum bum, or exclamation mark. So this is the input. This is the text that we are gonna try to tokenize, and we are gonna compare all these methods. We are gonna compare 5 methods. All of them, they are doing pretty much the same job. Of course, there might be some pros and cons for each and every method. So how many words that we have? So we got 1, 2. How many tokens we're supposed to have? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So in total we have 20 words, or 20 patterns, or 20 token in total. So let's compare the tokenizer methods on the sentence that we already know. So we created the functions. tokenize. The first one that we created is a function that tokenize an input using the tweet tokenizer. Then the second sentence using the WE tokenizer. Then the regular expression tokenizer is simply it splits this regular express. What it does, it splits it splits the sentence or the text into token and remove anything that is not alphanumeric. Then we tokenize using the white space tokenizer. Then we build a function that tokenize using the word pank tokenizer. And now we are going to compare. So to compare, all I care about is the length, is how many words out of the 20. So we already counted, we have a 20. So I supposed to get at least 20 if you remove 1, 2, 3, 4, 5. At least I think I'm expected to get 15 tokens. That would be perfect, great to go for the analysis. Let's try to see what we are going to get. So I am not interested in the entire sentence. All I'm interested is the length, how many tokens after we apply a function on our text. So token with tweet tokenizer is the function that we just created. This is the function. It is going to take the sentence, okay, as a parameter, as an input. Then it's going to tokenize it using the tweet tokenizer method, and we are going to get an output which is going to be the input being tokenized. Okay, so the first method is 20. It did not do anything. The second method is 16. To remove 16, it kept only 16, so it removes 4. It removed 4. The third method 16, and the fifth method 18, and the length, the fourth one, the white space 16, and finally the pank word pank tokenizer, it keeps 18. So based on what you already know by your data, comparing it with the result, it's totally up to you to determine which method that works better for you. If you were to look into the actual list, simply remove the len function, and here we go. So we got love to learn NLP. It keeps the 2021. It considers it keeps the punctuation. It did not remove it. It did not remove. Actually, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So yeah, it keeps it keeps everything. It keeps everything. So it did not do anything, or what it does, it simply tokenize. It's split the sentence, the given sentence into tokens, into words. So it got 20. So it did not do anything. The MWE, it removed 4, and I believe it removed probably. Sorry guys, it removed I'm expecting the digits. This is 1. This is 2. Actually, it removed the punctuation. This is 1, 2, 3, and 4. So if that's what you want, then we could go with MWE. The same applies with the yes, I think this is different. Yeah, okay. So the same applies for the regular express. It removes only 2. The white space remove 4, and word pank tokenizer, it removes only 2. So I would probably go with MWE since it token and it removes all the punctuations from our text. So now we know what works better for the sentence that we already know, and now we are going to apply the same on the original sentence. So let's override our sentence. So if we were to look into this sentence one more time, it is going to take the form. It's actually the sentence that I created, and now I'm going to override it with the paragraph that I copied from the Yahoo article. Okay, and now we are going to apply the WE function, tokenizer method. So we decided to go with that. It's totally up to you. Whatever method that you want, it's totally up to you. So we could use, as I said, we could use the MWE, since it has a better result, or the white space. Okay, so we are going to apply that on the text, and we are going to, of course, we are going to have different number because we have now a paragraph with many words. Okay, so we got 56 for tweet tokenizer. We got 54 with MWE. We got 57 with regular express tokenizer. We got 54 with with white space tokenizer, and finally we got 58 with word pen tokenizer. As I said, we got 5 methods to tokenize a certain text. Use whatever method that you prefer. After, of course, you test it on a given noun sentence. Okay, after we tokenize, of course, some of these, let's say that we want to go with we want to go with MWE. Okay, let's take a look. So now it tokenized it for us, but there is a lot of we could have some words. You could have many words in there that have the same root but different suffixes, different endings. So what we could do is we are going to apply the stemming. Stemming is simply it does look into the word, and it keeps the stem or the root of the word, and it removes all the addition or the ending. And there are many methods again for the stemming. One of them is a regular express stemmer and porter stemmer. There are other methods. Again, you could try them, both of them, on a given known data or a known paragraph or a known sentence. After you apply it, you determine which one is better, works for a known data or a small data set or small sentence. And after you make a decision which one works better for you, then you apply it on your entire data set. So for this reg express stemmer, it's a method that we need to import from NLTK. So NLTK stem, we import the reg express stemmer. So we import the method. Then we are gonna create a function. So this is all about functions. If you are not good in creating functions, then you might need to invest sometimes, or you might need to put some effort to learn how to create customized functions in Python. So we create a function that takes one parameter, one input, and we apply the method that we just imported from the library. We apply that method on the text, and we then we concatenate, and so we apply the method on the text after we split the input. Then we look through those inputs, now the tokens of the input and concatenate them. Very simple. So I'm going to run this to create a function. Then this is the function I created. I'm going to take the function and I apply it on my sentence. I apply it on the sentence here that we copied from the Yahoo article. Okay, so we apply it on the Yahoo paragraph. Okay, so we are going to import, we are going to create the function, and now we apply the function on the sentence. And here we go. So probably we don't have any word with the suffixes. So actually we got the unlocked. So it should be unlocked. Their house, parents did not. Anyway, so I don't have time to go through every and each word, but this function could tokenize words and stem them accordingly. And the same, this is one method. This is the regular expression method, or we could do the porter stemmer. Of course, they are different, and I don't really know what's the actual difference between them. But we could try them on a small sentence to see how they behave accordingly. The port stemmer is the most common stemmer that deals better with English words. I don't know if it works better for other languages, including Arabic. I have no clue because I never used it in those languages. But it works better, and this is the most common stemmer that used with English words. So we are going to import the stemmer from the library. This is the first thing we got to do. Then we are going to create a function. It's simply a function that takes one parameter, one input, and that input will be applied. Now then we apply the stemmer, the method. We apply the method on this input. After we tokenize it, we split it into words, and the stemmer it looks through every single token one at a time, and deals with the words that have suffixes by removing the suffixes and the ending. So the problem with this stemmer, unfortunately it does create some problems. It creates some problems. As you see here, the original sentence. In the original sentence, we have. Let's compare. So we got here the gun had been stored. We got this is past tense, stored ed, stored it removed d. Okay, so it removed the d. No, d in there. Unlocked, it removed the d. So it removed ed. Drawer in there, house, and parents. So it removed the s. Parents removes an s. Did not ask where it was when they called. It removed the ed. To the school the day of shooting ing. It removed the ing. Okay, for disturbing is disturb, it removed ing. Drawing, remove ing. Their son made of a firearm. Said, it kept it, etc. So the problem with this stemmer, sometimes it creates some of these spelling problems. So it creates, you could end up having a word that is not an English word. It's a garbage. It does not have any meaning. And this is where the lemmatization comes into the picture. Lemmatization is an advanced stemming process, stemming concept or technique. It's very slow compared to the stemming because it does stem and at the same time compare the stemmed word, the remaining or the root of the word with the online dictionaries, and it does use an algorithm to compare, to compute the distance, to find the closest word in a dictionary, the closest word in the dictionary to the word that we just stemmed. And it could be, you could end up having 5 words that are very close to the word stemmed, and of course it has to take a decision which word is higher, with high probability closer to the stemmed word. That is called lemmatization, which, as I said, it does the stemming and it compares the stemming with a given, with the dictionary. It's called WordNet. Okay, so we are going to import from the library. We are going to import the WordNet lemmatizer. So it is going to stem and it's going to compare it with an online dictionary called WordNet. So the process is the same. It is going to tokenize the given text. It's going to tokenize. It's going to split it into small unit, the smallest units, and which are called tokens or tokens. Sometimes we call them just words. And it loops through, it navigates through a word, one word at a time, very quick, very fast, right on the fly, and looks for those words that have an ending, words that have suffixes, and remove them. And as I said, compares the remaining word or the remaining root of the word to an online dictionary, to the WordNet dictionary, and fix accordingly. So that is what we are. So import all the functions, all the methods. Yeah, here we go. So we got it downloaded, and now we are going to create. Yeah, we are going to create a function. It's called get lemmas. Then it takes an input, one parameter. It takes our text, and of course it tokenizes it, number 1. Then after it tokenizes it, it's going to lemmatize it. So when it tokenizes it, then it's going to loop through, it's going to navigate through every single word one at a time. It lemmatizes it by applying the WordNet lemmatizer, and after that it joins back the remaining tokens, so it makes one sentence. So let's take a look. So we got here sentence. So this is our the given text. Okay, and now we are going to apply, we are going to create the function. Simply create the function get lemmas. As I said, this get lemmas function, it takes one parameter, it tokenizes it, it split it into smallest units, then it navigates through them, lemmatize them using the WordNet dictionary, and join them. So it reads from from right to left. Okay, create a function, and now we are going to take the function and we are going to give it the one parameter that it accepts, one parameter. There we go. You see, it takes a second. When we run the same sentence on the get stems, very fast, because there is no. It's simply what it does. It looks for the words with suffixes and remove them completely. It does not care about the spelling. Whereas the lemmatization is very slow, but it's more the performance is better. It's very slow, but the performance is better. And as a matter of fact, in one of the interviews I had in the past, I was asked what is which method of preprocessing in NLP method faster. I was asked if lemmatization or stemming is faster, and of course lemmatization is very slow compared to the stemming, because it does the stemming at the same time it compares the root of a word with a given dictionary to correct the spelling of the root. So that is I would say Lemmatizer is an advanced, as an improved advanced stemming method. Okay, of course, so now we stemmed, we lemmatize, and what we need to do is to remove the common, remove the stop words. So we need to remove so we got the sentence, it's already been stemmed, lemmatized, but we still have some punctuations, apostrophes. We got some, we got some, actually, it's there was a misspelling there. So you got some stop words or noun words, common words. They had been, and there, and so we want to remove all of this. We want to remove all of the this is what we call stop words. Okay, to do that, as we did in last week, is we are going to import the method, the word the stop words. As I said, this stop words, it does support I believe 14, 15 languages, including Arabic. So but we are going to use English since we are dealing with an English text. So we import, the first thing we do is we import the some of the methods. We import the stop words, we import the word tokenizer. We always need to tokenize our text. We need to split our text in the smallest unit, and that makes it easy to navigate through and compare this smallest units with the stop words list and English stop words list. And if there is a similarity, 100% similarity, we remove, otherwise we keep. So that is what it does. Okay, so we import the methods, we set the type of the stop words we are going to use. In our case, we are going to use English, and this is our sentence. So we are going to take this sentence, number one, okay, then we are going to lowercase it. So we are going to we are going to transform uppercase to lowercase. Why is that? Because sometimes, this is a case sensitive. Friday with capital F is totally different than Friday with lowercase f. So if we have another Friday in there with lowercase f, it is going to be considered as two distinct words, and that would make it very hard for is gonna deviate your statistics. It's going to simply corrupt your statistics. So we want to make sure that we have one word of similar words with the same case, or either uppercase or lowercase. So we are going to transform the entire paragraph into lowercase. Then we are going to tokenize them. Yeah, we are going to tokenize them. Simply, we are going to split them into smallest units. Then we are going to compare them with stop words, the English stop words, and we are going to keep the words that they are not similar to the given stop words list. Okay, so we are going to create a function called we are going to remove stop words. So this is a function. It takes only two parameters. It takes the input, which is two inputs, which the first input is our text, and the second input is the list of items, the list of stop words. So two inputs, then we are going to compare them, and if there is a a word or a token that looks that similar to a given stop word, then we remove it, otherwise we keep it. Okay, run. We just created the function, and now we are going to apply the function. We are going to apply the function on the sentence. This is the sentence, the text, the given text, and we are going to compare it with the stop words. Here we go. So if we were to do here length of the sentence, so let's see how many words that we have in the original given text. So we got 297, and after we remove the stop words, let's see how many words that we have. 192. So almost 100 words, 100 tokens wouldn't add any value to our analysis if we were to keep them. And this is only a paragraph. What if we have, a larger text, with many paragraphs and thousands of words? So if we were to keep all the stop words, of course, few things are gonna happen. You still can apply NLP on that text, but it's gonna slow the process. And number two, all what you are going to get at the end is most frequent words, which wouldn't add any value to your analysis. So we remove the stop words. Then all what we did so far, we imported our text, we lemmatized it, stem it, then we clean it, we remove the stop words, and now we got the final. We got the final output, which now we are going to use to transform. Yeah, again, use to transform into to extract some features. So this is what we have. Still, for a reason, it still keeps. Yeah, we might need to remove the punctuation and the apostrophe. Okay, but this is all what we have. Okay, so now we are gonna learn how to extract features. There are two methods to transform a text into sparsity matrix, into rows and columns. So general features method, and it's statistical calculations of some of general words, and specific features, and these features are dependent on the inheritance meaning of text represented within the given text. So there are two methods that you can utilize to extract, to transform a feature, to transform a text, a given text, or preprocess text into a tabular format, into rows and columns. Okay, so of course we are going to import some of the methods. So we are going to import the pandas library, we are going to import the string library, NLTK library, and of course we are going to import some methods. So we are going to transform, we are going to learn the part of speech of this sentence. And as a matter of fact, for the part of speech, we are going to try to learn the tagging. So this is the most common tagging. CC stands for coordinating, and I'm going to share this article with you guys in the chat. Okay, CC coordinating conjunction, CD cardinal digit, DT determiner, XE experiential there, foreign word, etc. So we want to extract this tagging from the given text. So we want to extract the tagging from a given text. So we are going to import the post underscore tag. This is the method we are going to use if we were to extract the tagging from the text. Of course, we are going to tokenize it. Tokenization is an essential part of the process. You cannot stem it. You will not be able to stem your text. You will not be able to lematize or remove stop words if you don't tokenize it, if you don't split your given text into smallest unit. Okay, here we go. And so simply import the methods, import the libraries, and we are gonna import a given tag sets. So we are gonna import a list of tags from the library. And so we create a function, and the function is simply the list of given tags from the package, and that is what we are going to compare. With the given text later. Okay, so these are all the the tags. So ls, ls stands for list market. For example, to. So to is an infinite marker. Another one, VBN. It starts for verb past participle, VBN, etc. Okay, so we are going to create a function. A function is simply a name, and it takes two parameters. It takes our data, it takes our two inputs, our text, and it takes also the list of the tags that we downloaded from the library. So it takes this list, and it takes our data. It will take our data, and it will take the list of tags. And of course, we want to apply the tagging for this. We want to apply the tagging for the given text, and we want to count. How many tags we have per word. That is what we are going to do. So this function, it takes two parameters. It takes the two inputs, the data and the list of tags, and it compares them. So it compares the text, the given text, with the list of the tags, and of course it applies the tagging on the text, and it counts how many tags that we have for the entire given text. So this is the function. I'm not going to go through every single piece of it. I'm going to simply run it. So this is a function, and I'm going to set the column. Let me shut this on for now. And so I am going to create a small data set. So create a small data set, simply a small data set with some sentences from the same article. So this is the first. This is the title, or this is the header. So the header is a text. You could name it whatever you want. Then I copied a few sentences from the paragraph from the article. Then I created a small data set. Okay, so we are going to load that data set, and then we are going to apply the function that takes two parameters. As I said, it is going to take the PDF file, the CSV file, and it's going to take the tag list. It's going to take this list, and it's going to tag our sentences, and it's going to count it's going to count the number of tags that we have per that small data set. Okay, so I just created the function, and now we are going to import the data, and we are going to display. We import the data. Then we are going to apply the function we created above. Here we go. So this is the list, It is going to count how many LS we have, how many TO, how many VBN, how many punctuations, WP, UH, etc. So you see, you cannot see everything, unfortunately, because the Jupyter Notebook is limited to 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be 10. It's going to be 10. It's going to be, it limits to 20. So this is 10. The first 10 and the last 10. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if you want to, and we got some dots in there, if you want to see everything, then we need to set the maximize. We need to change the parameter of the maximize of the column display. So it's a pandas option. So pandas method. So we set the display to maximize, maximum columns. I put it into the 70. I know we don't have a 70. You could put it with the max. So now if I run this, if I change the parameter to 70 instead of 10, 10, and dots. So now if I run it one more time, then there is no more dots. So you are going to see everything. Here we go, and you can scroll in and out to see everything. So in our data, we got here we go. We got 15 sentences. We got 15 sentences, and you got and because Python starts with 0, so we start the 0, 1, 2, 3, 4, and 5, and so we display the first 5. The head function displays by default the first 5 elements, the first 5 records starting with 0. So if you want to override that, we are going to add this number 16 because we have 16 sentences, but because we start with 0, we only need the 15. Now we are going to see all the 15. So the sentence, there we go. So this sentence here, it has 0 ls, 0 to, 0 VBN. It has 1 verb, BVG, 1 GG, JJ, 1 NN, 6 NN, and 1 WT, no parents, 1 dot, 1 dot. Here we go, this one. So, and it continues until it does cover all the list of tags being loaded. So this is how beautiful it is. And now we created a matrix, and we could utilize this matrix to extract some meaning. We could use a machine learning on this matrix if we were to, and we could use a lot of statistical modeling, scientific method on this text. So we started with a text, no structure. There is no structure in there. It's totally, I would say, impossible to use any machine learning, any statistical analysis, any scientific method on this unstructured data. But now we have a tabular format that we created using the tagging and the counting of the tagging on the corpus. So we got manually created corpus. We transformed the entire paragraph into a tabular format, into rows, into columns, and rows. So now we have rows and columns. We can definitely apply machine learning. If we were to, we can definitely apply some statistical analysis, data visualization, etc. So we have rows, we have columns, and we have rows. So this is columns and rows. So we were able to transform unstructured data into structured data. But this is one method. There are other methods that we could use. All the way to the bottom. we could use this is the most important one, is bag of words, count vectorizer, one method. So we are gonna try this, and next week we are gonna build a machine learning on this bag of words or structured data. So what time? Yeah, it's almost 30 minutes. So I'm gonna skip some of these functions, unfortunately. But let me do that very quick. So we are going to create multiple functions that with two parameters, with two inputs, a given two inputs, and of course we are going to use the lambda function to remove punctuations, to remove to transform everything to uppercase or lowercase, to remove to transform everything to lowercase, to transform to check everything if it's numeric or non-numeric, to check everything to see if it's digits or non-digits, and to tokenize, to remove anything that is not string. So very simple things, if you were to, for example, and this given text, if you were to count how many string that we have, how many words that we have, how many punctuations that we have, how many digits that we have, we could do that using this function that I just mentioned. But I'm going to run this very quick. And so I'm not interested, but I'm going to run them anyway. So we are going to create a function called add punctuation count. So simply what it does, it is going to count how many punctuations that we have in the entire given corpus. So it takes two parameters, and we are using the lambda, and with the intersection function, which simply counts how many. Then it simply what it does, it is gonna count for us how many punctuations that we have on the entire corpus, an entire data set. Very quick. I'm gonna run it. Then take a look, and we got in the first sentence we got 3. The second sentence we got 3. The second sentence we got 1. The third we got 3, etc. If we were to calculate, how many capitalized words that we have, is the same process. We are going to create a function, takes two parameters. We are going to use the lambda function. Then it is going to simply loop through every single word after tokenized, every single tokenized word of the corpus, and is going to compare, is going to look into it as if it's uppercase or lowercase. If it's uppercase, it's going to count. If it's not uppercase, it's not going to count. So run the function and apply the function of the entire data set, entire given text. Here we go. So in the first sentence, we got 11 uppercase tokens or words. In the second, let's take a look. So this is the first sentence. So we got Deering is 1, Auckland is 2, country 3, sheriff 4, 5, 6, 7, 8, 9, 10, 11. So yeah, it's 11 uppercase words in that sentence. For the second one, 1, you got V as 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it should be 8. We got 8 capital uppercase words in the entire corpus. We are going to do the same. The only difference is the function that we're trying to compute or trying to investigate. So now is a lowercase. So let's find out how many lowercase case words that we have in the entire corpus, and one document at a time. So we create a function that takes two parameters. We are using the lambda function, and it looks for the lowercase. The first one looks for the uppercase. The very first one, it looks for the punctuations. The second one looks for the uppercase. The third one looks for the lowercase. So let's do the lowercase, and now we are going to apply it on the given data. And for the first sentence, we got 26 lowercase words, 29. The second sentence, we got 26. And I believe the sentence number 12, this is probably the longest, the largest sentence. It got 51 lowercase. Then we are gonna look into now compare if it's an alpha, is it character, non-character. We are gonna create a function, text to parameters. We are using the lambda function, and we are gonna loop through the tokenized text and compare it to is an alpha. So if it's yes, count. If it's no, don't count. There we go. Then we are going to apply it on our data. And so we got 204 characters on the first sentence. And if we were to do 15, and we got 221 on the 12. Yeah, 221, because this is the largest. 221 characters on the 12. Okay, now we are going to compare, is it a digit, is it a number. We are going to create a function, take the parameters using the lambda function to loop through tokenized words and compare them to a digit. Is going to check them, is going to check the type of the token. If it's numeric, if it's a digit, count it. Otherwise, don't mention, don't count, don't include. So we create the function, then we apply the function to our data, and now we are gonna display the first 5 elements. So there is no digit in all of them. Let's check the entire corpus. Actually, we got in the sentence number 7. 7 is 7 because it's I'm sorry, sentence number 9, because that's with 0. It has 2. Let's check that. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8. So you got here 3 and 0. So you see that. So we got we got 3 and 0. There we go. Yeah, we got 2 digit in there. And in sentence number 10, it got 7. So this is 9, 10. Yeah, I got this one. So we got 20, 22, 26. And if you scroll all the way to the end, we are going to get other digits. So now we count how many words. Now we count how many words, how many string. In the first sentence, we got 45, 57 in the fourth. Let's take a look into the 16. Yeah, we got 67 in the 12, so this is the largest. Okay, and now we are gonna see. We are gonna look into the space. Is a space in there, a white space? So we are create a function again. It's just copy paste. Or what the difference only is the method or the functions that we are trying to investigate. So we create a function that takes 2 parameters. We use the lambda function to loop through the tokenized text, and is going to check if it's a space, count, otherwise just ignore. Now I'm expecting to have zeros. Actually, yeah, there's I'm sorry, not zero, space. So if you were to count the sentence, yeah, So for example, the first sentence, you are going to see how many spaces we have. So you have during, a space between during and a space between a and hearing, all the way to the end. So for the first sentence, we got 45 spaces. For the sentence number 2, we got 38, etc., all the way to the end. I'm sorry, 39, 32, 27, all the way to the end. Okay, and this is one method of analyzing a given text. To determine how many lowercase that we have, how many lowercase, how many string, how many digits, how many punctuations, and how many white space. To help, this process would help you to fully understand your given text. So we already transformed, transformed our text into tabular format using the part of speech methodology or part of speech process using the tagging. Now we are going to keep, we are going to use another method. It's called bag of words. It's a probabilistic method that find how many counts how many it transform a word, a token, into into digitized vector, and counts how many vectors that we have. In nutshell, without going into the mathematical behavior of this method. Okay, so we are gonna import the count vectorizer from the scikit-learn. So this is not an NLTK process method, it's a scikit-learn. And scikit-learn does, those who are not scikit-learn, and now I misspelled it. So scikit-learn is one of the most common library that I use for modeling. Sorry guys. There we go. So it does handle the three most common machine learning types: classification, supervised learning classification, where we have a binary, trinary, multi-class labeling data or target variable. Regression, we deals with continuous target variable. Clustering, there is no target variable. It's simply trying to understand the underlying structure of the data. And of course, we can use it for dimensionality reduction, modeling selections, and pre-processing. It's a great package that I used for data preparation, pre-processing, and also it's used for modeling, tuning, and optimization, and dimensionality reduction. So we are going to import the count vectorizer method from the scikit-learn, and we are going to create a function. And this function, it takes one parameter, and this is the corpus. The corpus is a collection of articles. I'm sorry, it's my apologies. It's a collection of documents. So if you were to look into this given data set, so this is a document 1, document 2, and 3, and 4. This every single sentence is considered, using the corpus terminology, is considered as a single document. So corpus is a collection of documents. That is the meaning of the corpus. So it's going to take a corpus, which is, as I said, is a collection of documents, and is going to tokenize it. It's going to then we are going to tokenize it. We are going to apply the count vectorizer. We are going to transform it into a matrix, and calculating how many vectorized, digitized representative of a very single word. So after that, we fit and transform. So it is the count vectorizer is a machine learning method. So it is gonna fit the corpus and transform it at the same time, and after that we sort using the bag of words or modeling. It simply is gonna count how many. It's gonna count the number of vectors that we were able to extract out of the tokenized corpus. So I'm gonna run this function, and now this is my corpus. So this is the corpus. It's simply the same documents, but I create a corpus with different sentences. So this is the first one, comma. So this is one document. It's 3 quotation marks because I'm afraid I might have an apostrophe or quotation marks within there. So I decide to use the 3 quotation marks to simply avoid confusion with single quotation marks or or double or an apostrophe. So we created a corpus with one sentence, the document. So this is the first document, comma, second document, comma, third document, fourth document, etc. So we created the corpus with 5 or 6 documents. Okay, let's create the corpus. So we got 6 documents. Let's take a look. So this is the first one. Yeah, this is the first document. Here we go. Comma. So this is the first one. Comma. Second one. Comma. Third one. Fourth one, etc. So we got 6 documents in this paragraph. This is what considered a corpus. A corpus is a collection of documents, and a document is simply a sentence. Okay, so how many sentences that we have? The length of this corpus is 6. Okay, so we want to vectorize, we want to transform this structured data, which unfortunately as far as I know, no machine learning can help you to model this data unless it would transform it first into a tabular format. There might be some algorithms that does that on the fly. I am not aware of them. So if you know of any, please go ahead and sorry guys, I need to thank you Fatima for handling this remove. Okay, sorry guys, my apologies for the chat. Someone is disturbing the chat, so I was not aware of that. Anyway, I think Fatima handled it. So we created the corpus, and now we are gonna so we created the function number 1, which applies the count vectorizer to a corpus. We created the corpus with 6 documents, 6 sentences, and now we are going to transform it into sparsity matrix. Here we go. So the sparsity the columns are simply out of this 6 documents. It simply looks into the most frequent words or the unique words. So we have a list of all unique words. So we got 235 unique words out of these 6 documents. So like for example, we got a unique word, 15 unique token, and 15 in the first document we got a 0. Second document we got 0. The third we got 0. The fourth we got 0. The fifth got 0. The sixth we got 1. The second word, the second unique word out of this 235, it's all zeros except in article in the document number 5, starting from the 0. So this is one way of transforming the unstructured text, unstructured data to a structured data. So we could use now this structured data to apply data visualization. We could apply statistical analysis. We could apply modeling, machine learning, deep learning to model it and extract some meaningful information. So we started with unstructured data, and now we have a tabular format, tabular data, and this is what we are going to need for modeling, and for not only modeling, for extracting some statistical information, visualization, trying to visualize this the given data. So we had unstructured data, which no machine learning, as far as I know, can help us to handle it as is. But now we transform it into tabular format, into rows and columns. We can definitely apply any statistical modeling, statistical analysis, descriptive analytics, data visualization, and of course machine learning, deep learning. Okay, let me see. Okay, so so another technique, it's term frequency inverse document frequency. So another probabilistic method to transform the unstructured data into tabular format by simply calculating the probability of how important a word is for the for a given how important a unique word is to the document and to the entire corpus. So it does calculate the probability or the importance of a word within a document, within a sentence, and across the entire what you call the corpus. So I'm going to run this, and we should be able to end. So we import TF-IDF vectorizer from the scikit-learn. It's not an NLTK. So we import the Tokenizer. We are going to create a function, simply a function that takes one parameter, which is our corpus, which is our given data set transformed into corpus. And of course we are going to feed and transform. So TF-IDF is a scientific method, is a model, is an algorithm that takes this given data, is going to feed and transform at the same time. Okay, and it returns a list, and now we are going to apply this this function on our corpus, on our the corpus that we built above. And let's take a look. So it's going to give you a list of probabilities, zeros, etc. And of course it's unreadable, and this is one method of transforming the unstructured data into structured data. There are many methods, but trust me guys, the most common method to transform unstructured data into structured data is TF-IDF and the word the bag of words. Okay, finally, and probably yes, got 4 more minutes. Once we transform unstructured data into structured data, either using TF-IDF or bag of word, we can now look for the similarities. We can calculate the distances between words to see how close words are together, how far they are, and how close they are. There are many distance matrix that we can use, but the most common ones is Jacquard and cosine similarities. So I'll give you an example, and we are going to end up with this. So number one, we are going to import all the methods we are going to need in a word tokenizer. Again, tokenizing a sentence or a text is very important, otherwise you are not going to be able to apply any other methods. So we are going to tokenize, we are going to limitize. then we are going to transform we are going to transform our unstructured data into structured data using TF-IDF, calculating the probability of importance of a word within the documents across the corpus. And now we are going to calculate the similarities, how similar a word to a word or a sentence to a sentence. Okay, so we are going to create a function that uses the J-card or J-card similarity methodology. It takes two arguments, two texts, and of course it lemmatizes them first, it tokenizes them, and it transforms it takes the two input, it transforms them into lowercase, lemmatizes them, and then it unifies them. And at the end it is going to calculate the similarities and dissimilarities between these two sentences or these two texts that combine together. Okay, so I'm going to make one pair. Okay, so let's make one small data set. So it is, as you see here, so this pair, this is a sentence or a text. It is one sentence, second sentence, and third. Okay, so we got three sentences separated by punctuation. It could be a colon, semicolon, comma, whatever. And now we want to compare after we tokenize, we are going to tokenize all these sentences. Then we are going to tokenize them, we are going to lematize them, we are going to transform them to lowercase, and we are going to combine them. So we want to compare, let's say we are going to subset, or we are going to, what do you call it, I know there is a word, but I cannot think about it at this point of time. It's called slicing, dicing. We are going to slice. We are going to compare the 0th, for example, to the first, to the 1th, and the 2nd. This is second, and this is the 3rd. Okay, so we want to compare. We are going to use the function that we just created, and we want to compare the first sentence of the pair with the second. We want to see how similar they are, how closer they are. The higher value we got, the closer they are. The most likely they have something in common. Okay, so we are going to compare the first sentence of the first pair with the second sentence, and we want to see how similar they are using the cosine similarity. Is 0.03. They have something, maybe few tokens during a hearing that started around noon. So you get A in there, probably a V. So that is the only so this is only one token. They are similar, and that is 0.035. How about if we were to do, for example, I'm going to simply copy this. I'm going to copy this 4 words. I'm going to add them to the first sentence. Okay, I'm going to create another. I'm going to override. Let's take a look. So now we got the first pair. The first sentence of the pair has the word Auckland County Sheriff Officer, and the second one has the same. We want to see how similar they are. So we are going to compare the 0th, the first sentence of the pair, with the second. I'm expecting to have a better value, hopefully. Here we go. It's 21%. So 21%, the first sentence is similar to the second sentence. So and we could do the 1 and 2, 0 and 3, etc. We could compare as many as many sentences within a paragraph, within a corpus as possible. Okay, and and we could use as I said, we could use the Jacquard or cosine similarity by simply creating a function. We create a function and we transform the given data into a tabular format. Then we provide or we apply a method that we are interested. Here we go. Pair number 2. So we need to create pair number 2. So we create a function. We compare the pairs. We create 4 pairs, and every pair has different sentences. Okay, we create the function. Now we compare, and after that we are going to use the cosine similarity. The first similarity we use the Jacquard, and now we are going to use the similarities. And let's we are going to use the same. Function, a different function for the same. For the same sentence. Let's see if we are going to get similar cosine similarity. Cosine similarity is not defined. I believe I am skipping. There we go. I think I'm skipping. I'm simply skipping something, and I don't have time to troubleshoot. But yes, we can definitely compare the cosine similarity and Jacquard similarity of sentences within a corpus, within a text. That gives us a sense of how similar, how closer they are, and how far they are. So, okay, folks, that's it for today. It was a pleasure again conducting this free program, and next week we are going to move into applying machine learning to a tokenized, a text that we are going to learn, that we already learned how to clean, how to pre-process, how to remove punctuations, how to transform into lowercase, how to remove the stop words, how to remove the white space, how to tokenize, how to limitize, how to stem, and how to transform into structured format into rows and columns. So next week we are going to learn how to apply machine learning. So we are going to build our first model. Next week we are going to build our first model, text classifier. So we are going to learn about machine learning, we are going to learn about supervised learning, and we are going to apply classifier method on transformed text. Okay, folks, that's it for today, and thank you so much for joining the program. Thank you so much for being a part of this free program. Please share the word with your network. We do appreciate that, and Assalamu alaikum wa rahmatullah. Inshallah, see you next week. Bye, everybody.